Hello, this is chapter 2, video number 4. This is the last video for this chapter. And today we're going to go ahead and talk about what makes a bad graph. So far, we have talked about different types of representations for qualitative data, and then we also talked about quantitative data with our bar charts or with our dot plots and our histograms. And then we also talked about how we can describe those graphs. Now, the last thing we're going to talk about is what is a bad graph. I am swimming in bad graphs right now with the COVID crisis. So, we are going to go ahead and talk about what makes a bad graph. And if I were to choose one lesson that you take with you, regardless of what profession you go into, it's this: how to spot a bad graph and call it out. All right, so first mistake of bad graphs is when we are messing with the vertical axis scale. So I'm going to go ahead and show an example. All right, this is on our local news every single day. They post things like this on Facebook and on Twitter. And I want to talk about the vertical scale here. So at 9 a.m., it is 32 degrees, and then we're up to 36, and then finally 39 and 41. 37 and 33. And if you look at the scale here, we went from 32 degrees all the way up to 41. However, it looks like we jumped from 32 degrees like this. If I were to multiply this 1, 2, 3, 4, 5, 6, 7, this is 7 times the height that this is, but we are not 7 times the temperature. It is not 200 and over 200 degrees outside. So be careful. It looks like you really peaked in temperature when in all actuality it only went up by 9 degrees. So always try to start your vertical axis at 0 so then you can actually see what the actual change is. So that is a vertical axis scale. Now the same thing can be said for the horizontal axis, especially over time. So the horizontal axis, let's take a look here. All right, so this is kind of a double offender. Now, looking at this graph, it looks really bad that our gas prices have skyrocketed. If you look at the height right here and the height up here, it looks like gas prices have doubled or almost tripled. However, first off, let's look at our vertical axis. We started at $2.90. So this huge jump from 317 to 357, that's only 40 cents. Which is significant, but it's not as significant as this is making it. Now let's talk about our horizontal axis, our x-axis. We went from last year to last week to current. The jump from here to here is not the same as the jump from here to here. So make sure that your x-axis is going by the same, going at the same rate, so that there's no really big jumps. Very similar to this graph. Notice it was every single year. We're in order. We didn't jump from like 95 to 2005 and then to 2006. These are all evenly spaced out. So be careful with your axes. Make sure that you start at 0 when at all possible, and then make sure you're going up by the same rate. All right, area principle. My favorite bad graph of all time is this one. All right, so this one is talking about average female height. Area principle here, it looks like women from Latvia are the tallest. They have an average height of 5'5", and women from India are the shortest. They have a height of 5 foot. Now, not only did we not start this vertical axis at 0, take a look at these areas. The area that is covered by this Latvian woman versus this Indian woman. We could fit one, two, three. I would say we could fit a dozen of these in here, but this woman is not 12 times taller than this woman. It's 5 inches. So make sure that the area does not change significantly. Make sure it's representative of how much it is. If this woman truly is 12 times 12 or 20 times larger than this woman, by all means use an area representation, but be careful with that. Same thing goes with volume. I have yet to find a 3D graph that I have liked. 3D graphs are typically bad. Very rarely. Everyone thinks that if they choose 3D in a graph, it makes it look cooler, but that is not the case. So here is an example of the bad volume principle. All right, so this is talking about annual salaries. So the annual salary of somebody without a high school diploma is around 18,000. High school diploma is around 27, bachelor's is around 51, and then an advanced degree. Wow, look at all that money. Now, I want to be careful of the volume principle, and I want you to think back to Legos. Imagine this is one little piece of Lego. This is one little Lego. And I want to think about how many Legos of these fit in here. Well, looking at this size, it looks like this would be about a three or four, a 4 by 4 by 4. So this would end up being 64 times greater. There are 64 of these little things that could go in there. However, is that 64 times the salary? No, if I multiplied that by 64, I would be over $1 million. This time 64 is going to be well over a million. So this is not representative of it. It makes this degree seem much more worthwhile. It makes it seem 64 times greater. Well, it's actually not 64 times greater. All right, so careful with your axes. Area principle. Be very careful to make sure that the areas are representative and proportional. Volume principle. Don't use 3D graphs. They rarely work. And my last one is bad pie charts. Let's take a look at this pie chart. Ugh. This one was seen in the wild earlier this summer. This is talking about your biggest COVID-19 worries. And it looks like 48% of people were upset about or were worried about getting it. Family getting it was 62%, and then finally the economy was 68%. One big issue, these do not add up to 100%. It seems like some of these people were double counted. They didn't ask, this doesn't add up to 100%. So there are some people that obviously fall into multiple of these categories. Maybe they were worried about both of these or both getting it and the economy, but this represents much, much greater than 100%. So nice try, but bad graph. All right, so please, 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 when you graduate this or finish this course, be careful of these 5 things. Don't get fooled by vertical axes. Don't get fooled by the area principle or the volume principle. And then finally, please make fun of bad pie charts.